Okay, welcome back to the Algebra 2 final exam review. In this video, we're going to cover section 10, which is working with properties of exponents. So, in the first section, we're going to use this property that a to the n times a to the m is equal to a to the n plus m. Now, I'm not going to go through and derive this property because I've done it a few times in class. However, jumping right in to number 109, we have that 4 to the negative second times 4 to the third. And using this property, we want to evaluate this. Well, what this means is that from this property, if we take, as long as these bases match, so we have a 4 and a 4, so we have an a and an a, we take these two numbers for the exponents, so we have negative 2 and 3, and we just add them together. So we'll have 4 to the power of negative 2 plus 3, which is equal to 4 to the first power. And if we simplify that, anything to the first power is itself. So this is just equal to 4. For number 110, we have 2 squared times 2 cubed. And again, this is equal to 2 to the power of whatever these two numbers are added together. We have 2 plus 3. So this is the same thing as 2 to the fifth power. For number 111, we have 2 to the negative second times 2 to the fourth. And again, we add these two exponents together. So we have 2 to the power of negative 2 plus 4, which is the same thing as 2 to the second power. For number 112, we have 3 to the negative fourth times 3 to the negative fourth. So we take our two exponents and we add them together. We get 3 to the negative fourth plus negative 4. So really what that means is 3 to the negative fourth minus 4. Combining that, this is equal to 3 to the negative eighth. And I mentioned in the instructions that your answer should contain only positive exponents. So if we ever have a negative exponent, it's best to express this using this property that a to the negative n is equal to 1 over a to the n. And so, in this case, we can just replace this negative 8. We can just write 1 over 3 to the positive 8th power. So, if we have a negative exponent, just do 1 over, in this case, 3 to the power of, flip the sign here, and we get 8. All right, so that was 112. Let's look at 113. For 113, we have 3 to the 0th times 3 to the 4th. So we add these two exponents together. 0 plus 4 is still 4, so we just have 3 to the 4th power. For number 114, we have 3 squared times 3 to the 4th. We add these two exponents together. We have 3 to the power of 2 plus 4, which is 3 to the 6th. For number 115, we have 2 to the negative third times 2 to the negative third. Add these two exponents together, we have negative 3 plus negative 3. This plus a negative number means that really we're just subtracting, so we have 2 to the negative third minus 3. And that gives us 2 to the negative 6th. And similar to number 112, if we have a negative exponent here, all we have to do is do 1 over 2 to the power of, negate this, and we have to the positive 6th power. So that's number 115. Let's look at number 116. For 116, we have 3 to the negative 4th power times 3 to the 0th. This is equal to 3 to the negative 4th plus 0. We just add our exponents. So we have 3 to the negative 4th, which is equal to 1 over 3 to the 4th. For number 117, we have 4 to the negative 3rd times 4 to the negative 1st. So for this one, this is equal to 4 to the power of negative 3 plus negative 1. Because we're adding a negative number here, this really means that we are subtracting 1, so we have negative 4 to the negative 3rd minus 1. This is equal to 4 to the negative 4th. And converting this to a positive exponent, we have 1 over 4 to the 4th power. And for 118, we have 2 to the 3rd power times 2 to the 0th power. And this is equal to 2 to the power of 3 plus 0, which is 2 to the power of 3. And we're done. So let's look at number 119. Yeah, we can fit that one down here. Oh, sorry. There we go. 119. So we have 2 to the power of 3 times 2 to the negative 2nd. This is equal to 2 to the 3rd plus negative 2, which is equal to 2 to the power of 3 minus 2, which is equal to 2 to the 1st. And of course, we don't need to write to the 1st power. We can just write that as 2. Okay, and for number 120. This one, we have 4 times 4 to the 3rd. Now remember, anytime we have no exponent present, it really means to the 1st power, because any number to the 1st power is equal to itself. So what we have here is we have 4 to the 1st plus 3, which gives us 4 to the 4th power. So that concludes the first 12 problems, where we're using that, again, using this property, a to the n times a to the m is equal a to the n plus m. For the next 12 problems, we're using another property. For now, we're going to use a to the n to the power of m is equal to a to the n times m. So with this property, now we can proceed with number 121. So with number 121, we have 4 to the negative 3rd in our parentheses, and then this to the negative 1st power. So this is equal to 4 to the negative 3 times negative 1 power. Negative 3 times negative 1 is positive 3. So this is 4 to the 3rd power. For number 122, we have 3 to the negative 3rd to the negative 4th power. This is equal to 3 to the negative 3rd times negative 4th power. Negative 3 times negative 4 is positive 12. So we have 3 to the 12th power. For number 123, we have 3 to the 0th power to the negative 2nd. So that means we have 3 to the 0 times negative 2 power. Anything times 0 is 0. And so we have 3 to the 0th power. And if we want to simplify that, we know that anything to the 0th power is equal to 1. So we can just say that's 1. For number 124, we have 3 to the 3rd power to the 0th power. This is equal to 3 to the power of 3 times 0. Anything times 0 is 0, so we have 3 to the 0th power, which, similar to the previous one, we have 1. Then we have, for number 125, we have 2 to the 4th power to the negative 3rd power. So this is equal to 2 to the 4 times negative 3 power. 4 times negative 3 is negative 12, so we have 2 to the negative 12th power. And if we write this with a positive exponent, we have 1 over 2 to the 12th power. For 126, we have 3 squared to the negative 2nd. We can rewrite this as 3 to the power of 2 times negative 2. This is equal to 3 times 2 times negative, 3 to the power of 2 times negative 2, which is negative 4. And rewriting this with a positive exponent, we can rewrite that as 1 over 3 to the 4th power. On the next page, we have problem 127. So for number 127, we have 4 to the 4th power to the negative 2nd. This is equal to 4 to the power of 4 times negative 2. And 4 times negative 2 is negative 8. So we have 4 to the negative 8th power. And rewriting with a positive exponent, we have 1 over 4 to the 8th power. For number 128, we have 3 to the power of 3 to the negative 2nd power. This is equal to 3 to the power of 3 times negative 2. 3 times negative 2 is negative 6, so we have 3 to the negative 6th power. And rewriting with a positive exponent, we have 1 over 3 to the 6th power. For number 129, we have 3 to the 3rd power to the 4th power. This is equal to 3 to the 3 times 4th power. 3 times 4 is 12, therefore we have 3 to the 12th power. For 130, we have 4 to the negative 2nd to the 3rd. This is equal to 4 to the negative 2nd to the 3rd power. Negative 2 times 3 is negative 6, so we have 4 to the negative 6th power. And to convert this to a positive exponent, we can write this as 1 over 4 to the 6th power. So for number 131, we have 2 to the negative 1st to the negative 2nd power. This is equal to 2 to the negative 1st times negative 2nd power. Negative 1 times negative 2 is positive 2, so we have 2 squared. For number 132, we have 3 to the 4th power to the negative 1st. This is equal to 3 to the power of 4 times negative 1. And 4 times negative 1 is negative 4, so we have 3 to the negative 4th power. And converting to a positive exponent, this is equal to 1 over 3 to the 4th power. So the last dozen problems of this section, we use this property that a to the n over a to the m is equal to a to the n minus m. So again, I won't go through deriving this because time, and I know I've derived this in class a few times now. So we have 133. We have 2 to the 4th over 2 to the 4th. And with this, we can say that this is equal to 2 to the 4 minus 4. So just subtract this number, this exponent, from the top one. So we have 4 minus 4. This is equal to 2 to the power of 0. And we can simplify that as 1, because anything to the power of 0 is 1. For number 134, we have 2 to the negative 4th over 2 to the 3rd. This is equal to 2 to the negative 4th minus 3. So this number minus that one. This gives us 2 to the negative 7th. And converting to a positive exponent, we have 1 over 2 to the 7th. For number 135, we have 3 to the 3rd over 3 to the 0th. This is equal to 3 to the 3rd minus whatever this exponent is, so 0. And 3 minus 0 is still 3, so we just have 3 to the 3rd. For... oh wait, I just realized I mixed these up. That was not 135. I was looking at 137 for the numerator, or for the denominator. So we have 3 to the 3rd, for 135 we have 3 to the 3rd over 3 to the negative 1st. This doesn't change our answer very much. But we have 3 minus 1, or minus negative 1. So that's going to be 3 minus negative 1. When we subtract a negative number, that means we actually add. So to be clear, that is 3 plus 1, which means that we have 3 to the 4th. For number 136, we have 4 to the 0th over 4 to the 0th. This means we have 4 to the power of 0 minus 0. 0 minus 0 is 0, so we have 4 to the 0th, which we can simplify as 1. For number 137, the one that I confused with 135, we have 3 to the 4th over 3 to the 0th. This is equal to 3 to the 4 minus 0 power. And 4 minus 0 is still 4. So we have 3 to the 4th power. And this is good as is. For 138, we have 2 to the 4th over 2 to the 2nd. This is equal to 2 to the 4th minus 2. This is equal to 4 minus 2 is equal to 2. So we have 2 squared. And this is fine now. For 139, we have 4 cubed over 4 squared. This is equal to 4 to the 3rd minus 2. 3 minus 2 is 1, so we have 4 to the 1st. And we could either leave it like that, or anything of the first power, again, is equal to itself, so we could just simplify that as 4. Okay, next one, we have 140. So 140, we have 3 over 3 to the third. Remember, anytime we don't see an exponent on a number or a variable, it means that it's to the first power. So this really means 3 to the first minus 3. Well, 1 minus 3 is negative 2, so we have 3 to the negative second power. And to convert this to a positive exponent, we have 1 over 3 squared. For 141, we have 2 to the fourth over 2. This is the same thing as 2 to the fourth. Remember, there's an implicit variable, an implicit exponent of 1 here. So we have 2 to the fourth minus 1. 4 minus 1 is 3, so we have 2 to the third power. For number 142, we have 4 over 4 squared. There's an implicit 1 for our variable. I keep on saying variable. Our exponent here. So this is 4 to the first minus 2. 1 minus 2 is negative 1, so we have 4 to the negative first. And converting this to a positive exponent, we have 1 over 4 to the first, but we don't really need that 1 there, so we can just rewrite this as 1 over 4. Next, we have number 143. For this one, we have 4 to the third over 4 to the third. This is equal to 4 to the third minus 3. 3 minus 3 is 0, so we have 4 to the 0th power. And anything to the 0th power is 1. Next, we have 144. This one is 3 over 3 to the negative first power. So implicitly, we have a 1 for our exponent here. Very sure to say exponent. So this is 3 to the first minus negative 1. 1 minus negative 1 means that we're just really adding 1 and 1. So 1 plus 1 is 2. And we have 3 squared. And so that concludes all of our problems for section 10. And so I guess that's it. Thank you for watching.